Hello, PyConline 2021. Welcome back to the education track. And it is my absolute pleasure to introduce Shrey Somaiya to give a talk on Python type hints and how they can supercharge CS education. This is very exciting. I want to know this, and I want this to be better. And I'm hoping that you, Shrey, will improve my quality of life through this talk. It's a big ask, I know,
No
but
pressure.
I reckon you can do it. Now, Shrey, I found a fabulous bio that Shrey did submit, but I didn't find it to begin with. And he said that I could make up anything about him. So I would like to start his bio by saying that Shrey's joining us following a wildly successful Olympic performance. I was just amazed at how true to form. You showed real courage and determination. I'm proud of you.
Thank you.
I'm
It
proud
was a
of you.
big stretch for me. Yeah.
But also, Shrey is a course administrator and tutor of Comp 1511, the Programming Fundamentals course in UNSW's School of Computer Science. He's been teaching in some form for most of his life and started tinkering with Python in early high school. Shrey is also currently co-president of the CSESOC UNSW, which is the Resident Computer Society of UNSW, which is one of our universities here in New South Wales. And he's leading a team of about 150 people to produce social events, podcasts, hackathons, career events, videos, workshops, peer mentoring, CTFs, assorted technical projects, high school outreach, and more.
Why did I write so much?
So many things. But you do so many fantastic things as part of it. So it's a fantastic society.
It's
and otherwise, Shrey, apparently you love cats, music, reading, and video games. And
I love cats.
Seems great. And I would say you also love Python. Yes, we could have had a cat on the stream.
Yes, that's quite sad.
Maybe next time. All right. Well, I'm keen to hear what you think. Shrey will be accepting questions, assuming I haven't taken up all of the time in this chat. So throw your questions in the StreamYard chat, and I will let you get to it.
Cool. Awesome. Thank you so much, Nikki. Cool. So, hello everyone. As Nikki introduced, my name is Shrey. Just a quick note on this talk. This talk is going to go through quite a lot, as usual. I want to talk about Python type hints, so we're going to go a bit of an introduction about what is a type, what is type safety, what are type systems, what are they useful for. We'll then go into the specifics of Python type hints and how we can look at doing those, and then we'll jump from there to using them in education, how we can use type hints to force students to design better, think as a software engineer, and actually do a full front to back sort of design of their program. So let's jump straight into it. And I'm hoping that I stick on time. Otherwise I'm going to get yelled at. So let's go. Disclaimer, I am not a genius. I'm not Guido. I do not know everything. I only know some things, and I'm going to tell you about those some things. I may be wrong, and please inform me if I am. Yes, thank you. Cool. So safety. What is safety? When we talk about programming languages and running our code, what is safety? I was reading a Stanford article that talks about safety as a vague term lacking great definition, and I was like, great, that's very useful for my PyCon talk. I'm going to slap that right in there. But for the purpose of this talk, we'll say something along the lines of, safety is about avoiding harmful mistakes. Now, when we run our code, when we run our Python code, we usually run into sort of two major problems. Our program crashes and burns, it halts, it stops, there's some sort of error and says, you can't do this, or this failed. Or we have like a human error, undefined behavior, unexpected behavior, something went wrong, but the program still runs fine. And so if only there was a way that we could avoid these behaviors as much as we could. Psych, there is, and that's called type safety. So a lot of type languages, such as C, Rust, etc., can attempt to enforce good behavior, including safety, by performing static checks when you run the code. So when you run the code, it scans through and checks, all right, you've said this variable is an integer, but you're trying to multiply it by a string. I can't multiply an integer by a string. I'm not going to let you run the code. So it doesn't even get to that running point. So this is what we call a statically checked language. The process of checking the code is called type checking, and the algorithm that does the checking is called the type checker. So if you hear me jumble those like language later on in the talk, that's what we're talking about. So essentially, every value has a type, and when you run the code, the operations on the value are checked per the type. Now, Python doesn't do this. Python does something different. Python's what we call a dynamically... Oops, I already talked about this. Yikes. Python does something different. Python does what we call dynamically typed language. Is a dynamically typed language, and we'll go over that in a bit. But in Python, we don't have these types, right? So why not? If it sounds so great, if we can avoid these errors, if we can make our code better, why don't we do it? And the answer here is convenience, right? Imagine if you had to specify for every single variable what type it was. It would be so slow to write your code, especially when you want to use Python for quick tools, right? So a lot of the time I'll use Python for doing some quick data munging or changing formats of stuff. I don't really want to make it work correctly. I just want to work it very quickly. I want to write it quickly. So we lose some safety, but we get a lot of convenience. So Python instead of having static typing, we have what we call duck typing, or dynamic typing. So what is duck typing, and how is that relevant to what I'm about to tell you? So duck typing is not this one. Duck typing is something like this. So Python, it only checks if you're allowed to do something. It doesn't check if it's it doesn't check it at compile time. It checks it when you're running the code. So for example, let's say you have a class duck. My cursor doesn't show. Let's say you have a class duck. This duck has a quack method. When you call the quack method, it will print out quack. There's also in this code a say quack function, which takes in a variable called duck. So when it takes in the variable, it'll say, of that instance of a class, of that duck, tell it to quack. So if we have a new duck called Jeff, and we say, all right, Jeff, say quack, Jeff will say quack. Cool, this works fine. This is as we expect. But what happens if we have a dog class, and this dog class also has a quack method? If we tell the dog to quack, it'll quack. And so duck typing essentially is, if it quacks like a duck and it walks like a duck, then it must be a duck. So if it's able to do the thing that you ask it to do, then that's fine. That's okay. And that's all we care about. So you might be wondering, oh my gosh, why are we talking about type systems and type theory? I thought I was here to learn education. And yes, as I mentioned, we'll get there. We'll get there, I promise. Assuming I don't get kicked out, but we'll get there. So I was going through some old HSC code that I wrote. So in New South Wales, there's a system called the HSC where students will do a series of subjects towards their final grade. And as part of the software design HSC subject, which I did as an elective, you have to write a massive major work. So I was going through a lot of my code for this talk to see if there was anything I could use as an example of code that was questionable and hard to understand. And I came across this function. This function is called getBody. It takes in a message. It checks if the message is multi-part, then it returns itself, or a get payload. So what is message? Is message some sort of class? Is it a function or a type from somewhere else? Like, what is multi-part? I've never seen it for at all. So looking at my code, it's very difficult to reason what it's doing and how it works. I don't know what message is. I don't know what it's supposed to return. There are so many things here that is very difficult to understand. And extracts the body from the email doesn't help at all. Until I read this comment, I had no idea this is about emails. So I wonder what that's looking at. So if I were to call getBody of hello, I don't really know what will happen here. And so, oh no, my error message didn't appear. Oh no. Okay. Well, if I did this, there's a big error saying you cannot run isMultipart on hello. So my Python code just stops and breaks, which is not good. We want this stuff to be checked before we run the code. So the way we can do this is using type hints. And so we can tell our function message is of type blah, and we can say, please only do this if this is correct, right? So if I say message is a string, this will run fine. If I say message should be an integer or a number, and I say get body of hello, my program will error saying, hey, you've made a mistake. You've passed in a string where I expected a number. So let's go over how to do some of that in Python. So in Python, type hints are written as annotations. Our type hints are completely ignored when you run the program, which is, you might be thinking, well, what the heck's the point then? Type hints are ignored for quite a good reason, which is that you shouldn't be forced to write Python code that has types, right? That shouldn't be mandatory. So there are actual tools out there where you run the tool on your code. A good example is something called MyPy, which is a very common Python-supported type checking program. and you run this over your code, it will then look at the annotations and it will check that you've done the right things. When you just run Python 3 in your code, it won't actually check your types. You can do something completely wrong. So as Python, we start as annotations. And so the syntax for this looks something along the lines of this. So for example, I have a variable called age. Age, I've said, is an int or an integer or a number. And that has a value of 20. So quite standard, you say your variable name, the type, and then the value. Groceries. Groceries is a dictionary of string keys to int values. And you can see I've initialized it with apples goes to 5 and chocolates goes to 3. And so there are a bunch of what we call basic types here. So integer, bool, float, string, bytes, list, blah, 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 blah. None is also a type that we can use. So a quick aside. Oh, that's not the quick aside I wanted. Back here, we have a dict. In earlier versions of Python, so previous to 3.9, you actually have to use typing.dict, so typing.D dict. And so you often see sometimes that sometimes people use capital D dict, sometimes people use lowercase d dict. It's encouraged that if you're using above Python 3.9, you'll be using the lowercase d dict, because I think it just looks a lot better. Like, why would you use typing.int, typing.dict, typing.list when you can just write dict list int, right? It's a lot easier to read. So just want to note that if you do come across this in the wild and you see an uppercase D dict or an uppercase L list, that is presumably using old typing instances. So we wanted to note that. So if I was to run this code, I've specified, all right, age is an int, age is equal to string 20. This should probably error, right? If I run this with a type checker tool like MyPy, it says incompatible types. You said age is an int, but now you're saying it's a string. And all of a sudden, we can really see the value in this sort of type checking. If I make a silly mistake later on the line in my code, and I make so many silly mistakes, trust me, I can statically check this before I run my code. Before I run my code in a server or I ship my code out to people, I can check everything is okay and there's no silly mistakes, rather than just running it or writing a billion tests. Now, tests are important in their own right, but this gives you some sort of static assurance, which is a common buzzword that you hear thrown around. Cool. So we've talked about variable annotations. Let's talk about function annotations. So function annotations have a similar sort of syntax where you have your function name and each of the arguments. Each of the arguments are annotated as variables. So for example, our nums variable or our nums argument is a list of integers, right? This is really easy to read. Your target is also an integer. Now the next part is a bit tricky. Traditionally with Python functions, you'd write, we'll go back to our example over here. All you need to do is write def, your function name, and in brackets your parameters, followed by a colon. When you're using type hints, you want to write your function name, your arguments, which are all typed, followed by an arrow to the return type. So in this case, our toSum function should find which two integers, and so it should return a list of int. So this is the syntax you'll see. It returns, with the arrow, a list of int, followed by the colon. In the case where your function returns nothing, which is often the case for some Python programs, you can just say it returns none, which is a really useful pattern to have. Sometimes people won't add the returns none part, which can make type checkers confused. Some type checkers will assume that you mean none. Some type checkers won't. You can also do parameters with multiple options. So for example, you say my argument is a string, or it's an integer, or it's none. Now, notably, this syntax for the union or the bar is only supported from Python 3.10, so I did bait you a little bit there. But you can use what's called a union. If you Google Python type union, you can do the same sort of thing. I just like the syntax a lot better. It's a lot easier to read. Cool. So I did some more research on this function that we were talking back about before. It turns out that my message is an email message. And it goes through the email and it checks if it's a message which has multiple parts, and it will get me a list of all those parts. So I added some types to this thing. I have to import email because these types are they're classes. So you can also add type annotations that are classes. So I can say my message is an email message class. So I have to import email there so I have access to that. So now when I run get body of test, it errors and it says, all right, argument 1 to get body is an incompatible type. It has string. I expected an email message. Please try again. So this is really, really useful. Now, looking at this code, I can clearly see, all right, I know what it's expecting. and I know what I'm going to get out of it. And so, without having to run the code, I can already do some manipulations on this, right? If I was just reading this code, I can say, all right, well, get body returns a list. I want to then have another function that will process the body of emails, and it will go through each item in the list. I don't have to waste time trying to figure out what it's returning or what it's actually giving, etc., etc. So you save so much time and energy and cognitive load. You just have to read this sort of one line to understand how the function works, which is really super useful. So let's hop back over to the education part of things. Type hints allow us to design our program first. When I was talking to some HSC students who were doing their software major works, I was talking to a lot of them about designing their program first. Don't just rush into things and code it all up. Design how parts of your program talk to each other. And they had a lot of trouble coming up with how to do that. And so this is how I thought of this talk, because type hints allow us to do this. They allow us to specify, all right, my function A is going to return a message that looks like this. Function B should also expect a message that looks like this and return a different type of message. And so all you need to do is write out the function prototypes, and then you can see how your program interacts. So, for example, I was doing a networks assignment for my university course. And so I wanted a way to have a user as a dictionary, right? Because I didn't want to do classes. Classes are too confusing for me sometimes. So I just wanted a dictionary. But I wanted the dictionary to have a special type. I wanted to be able to say, all right, this function should expect a user, this function should return a user. And so there's a thing called a typed dictionary, which you can use, which will allow you to make essentially a type, which is essentially a dictionary. And it's a bit confusing, but essentially my user dictionary has a password, which is a string, in a number of invalid login attempts, which is an integer, the last login, which is a date or time. The last login can also be none. And you can see the same pattern goes further on. So when I want to make a new user, all I have to do is say, all right, well, John is of type user. Remember, we have the colon to say this is of type blah. So this is of type user. And this is all the values for when we first make our new user. Now, this is really useful now, because when I'm designing my program, I can say, all right, well, I want a function that gets all the logged in users for my program. So let me just write out the prototype for this, what the function might look like. Get logged in users will return a list of users. Like, how useful is this? Now we can just say, all right, we don't have to think about anything else. We can just go through and design all the different things that we're going to need for our program. So I actually went through and I designed a whole bunch of functions and a whole bunch of types that I might need later on. And it was super, super useful and easier to sort of break down my program into multiple parts. So types allow us to not only have guaranteed safety, but they allow us to design our program a lot better. And this is why I think type hints and the future of Python typing is going to be super awesome for teaching. We can now design and teach about Python in terms of design first. No longer do we have to say, all right, just run your program, test with this, test with that. While that is a useful strategy sometimes, we can now also say, if we want to, oh, design out your code first and then go back and code it. So another awesome part of type hinting is documentation. For example, back on our email function, we can now see, if I was to send this screenshot to someone and say, hey, do you know why this isn't working? They can now see, all right, well, message is supposed to be this, and it's supposed to return this. If they wanted to look at, all right, what is multipart, they'll just need to Google the documentation for an email.message.email message. Or they could find it elsewhere in my code. And I've been sent screenshots of code before where the students are like, help, this is broken. And I've sent screenshots of code before saying, help, this is broken. And having these type hints allow us to communicate better with our tutors, with our students, about what the code is doing. What is it expecting? What is it going to return to us? How is it going to operate? And it also allows some sort of static guarantees. So when your student runs a code and say, hey, my code is broken, you can just say, hey, have you tried running your type checker yet? Have you done something obviously wrong? Which happens all the time. So I guess what I want to look up next is what's next. We've talked about where type hinting is up to today. We've talked about some of the stuff that's available in 3.10 with the bar union operator, but what's coming up next? What's coming up next is a lot of cool features, but I realize my slides are in order, and I'm so sorry for that. There are a bunch more Python type hinting shenanigans that I didn't really mention in today's talk, because we are time constrained. For example, generic types. If you want to say this function accepts a type T and returns a list of type T, you can do something like that. You can create your own types. You can pass in functions as types, so a callable type. You can say, all right, this function should return anything that's iterable, anything that implements the iterable sort of subclass. And so you can do a whole bunch of complex things with type hints. Type hints aren't just the basic stuff that I've shown today. They are very, very, very advanced. They have a lot of room to grow because Python was not made for this in mind. They were added on in 2015. But they are very, very advanced if you want to get into that level. So don't think that, your HSC students or the whiz kids can't use this. This is really, really good. And I think it's actually encouraged that they should use this because you get better documentation and awareness of how the code runs and how they can design their code. Here's the what's next slide. So what's next? So 3.10 hasn't been released yet, and it has some really cool typing features. So for example, type union. We talked about the type union. There are two also extra things which I'm not really going to explain too much, but essentially recursive types. So for example, if you had a type tree, and that tree has a field in it, which is a tree, aren't very well done in Python. You have to do a quote around the second type. It's a bit weird. If you have a look at it later, you'll probably run into this problem. But they are adding a feature to help that be a lot better. So a quick disclaimer before we wrap it up. MyPy and a lot of Python type checkers are still in beta. And they've been in beta for the last couple of years, for the last 5 years, because the language is constantly evolving. Even as I was running this talk, I was trying to show off the lowercase l list syntax when I was running my programs, and the latest version of MyPy actually didn't let me do that. I had to jump onto the nightly branch to have a look at using that. So just be in mind there are some things that are impossible to do with Python type hints. For example, a very common restriction is higher kinded types. So if you want a type that has a type, which you probably won't need, but if you do want to do that, that is something you can't do. Recursive types can also be a pain sometimes, and a bunch of super complex things. For the most part, though, Python types are really, really, really cool. And I'm very excited for the future. I'm very excited for how they can supercharge our education, how we teach, how we talk about design first, how we can improve documentation, how we can improve clarity of our code. And overall, I think they're a really great thing for the language, and I'm very excited to see where the future goes. But yeah, thank you so much for coming along, everyone. I hope you've learned something today, and I'll be taking questions for the next few minutes, if that's okay, Nikki. Hello. I cannot hear you.
Thank you so much. Thank you so. Sorry, the duck maybe isn't adding to the mystique here. Thank you so much. We do have a few questions, and there is time for a few more questions to be added as well. Now, the first question is simply a question of a duck with a question mark. How would you like to respond?
Duck.
Quack. Excellent.
Quack.
Fantastic.
Yes.
Great. Can you make MyPy figure out what types are instead of finding them yourself is our next question.
Yes, you definitely can. So MyPy has some functions. There's a particular function called reveal type. So if you print reveal type of a variable, it'll print out this variable is of blah blah blah, which is really useful for big complex code bases of a couple files or even larger. And you can just get a variable and you can say, all right, reveal what this type is. So yes, you definitely can, and a lot of them are built in mind to do that.
Fantastic. Excellent. Another question here. Which version of Python will this work for? You talk about 3.9 onwards. So, what about 3.6?
So, lovely chart. Type hinting was first implemented in 3.5. 3.6 onwards has support for type hinting. There are some features that aren't there. Like, for example, if you really want generic types or super complex stuff, 3.7, 3.8, 3.9 are your best. But yes, it does exist in 3.6, and you can do the basic stuff. You may have to do typing.uppercase D dict instead of a lowercase d dict, but that's just semantics. Everything else will work fine.
Excellent. Fantastic. Here's a question on why would you pipe int to none? Can none be implied if there's no int available?
So this is a really good question. I propose to you a counter question. Imagine I pass in a variable to a function, and for some reason that variable is turned to none. Now, if I am implying now that my function of, string or int should also take in none, the type checker won't error, and it'll say, all right, none is expected. But oftentimes you want it to error. You want to say, hey, for some reason, this is actually turned to none. whereas I was expecting a string or an int. So you should explicitly specify this should also accept none if that's a valid use case. Because sometimes things will turn to none and that's not what's supposed to happen, and you want it to yell at you an error and say, hey, something's gone wrong. So that's a good question. But yes, you should definitely be very explicit about those things.
That is a great answer. Excellent. Two more questions. One of my favorite things about typing as a dev is that it enables IDE magic for navigating around your code. There's more. This question continues. It's like an essay. It's fantastic. Our IDEs, the editor tooling types. Sorry, our IDEs and the editor tooling types. Are they able to enable useful things for teaching, or is the magic a hindrance in understanding how the system works? What are your thoughts?
So a lot of editors will analyze your types as you write the code. And so when you call the function, so oftentimes you write the function and use it later, right? So you write the function, you go to call the function, and it will actually hover and it will give you a preview saying, this function expects 2 arguments. The first argument should be an integer blah, and the second argument should be a string blah. And so oftentimes it won't do the magic of checking if you pass in a variable, blah, blah, blah. So it won't actually hinder you in that sense. I think that editors can be super, super useful when it comes to hinting, because they will enable that magic feature. And so as to whether it's too magic, that's a question that gets asked sometimes. Like, I don't want my students to have this magical popover of this is what it should expect. I want them to fail and learn the hard way, which is a valid strategy. That's totally okay. But I think you can disable those if that's something you're interested in doing. So I'm not entirely sure that answers your question. Feel free to ask me more on the hallway channel afterwards. But yes, they're super helpful for IDEs.
I think I have to agree that special magic can be ridiculously useful when helping students gain that sense of confidence. Like, oh wow, absolutely. I can actually do this. This isn't just. In fact, exactly. Almost ironically, this isn't just magic. I can use the magic, but then it also is handy to occasionally to feel like that they understand. They really understand what's going on under the hood.
Yeah. So everything's optional, which is great.
One last question. Unless there's another one that comes in now. Could we run MyPy as part of the GitLab CI command line interface?
I'm almost certain that is a possibility. I'll be very surprised if GitLab has no way to enable some static type checking. So I'm going to say 95% yes.
And leave that last 5% as an exercise to the homework for the viewer.
Google it. I'm guaranteed there's something there. Yeah.
Excellent. Well, those were the questions that our fantastic audience have come up with so far. And we are pretty much at time. So I am going to invite you, dear viewer, and you, Shrey, to join us in the hallway, in the education hallway track. Now, BYO beverages, please. And we'll have a good old chat about ducks and type checking and all sorts of things before you all rejoin us here for our next talk by Andre Roberge entitled It Doesn't Work. Which I just love it. I'm not sure what it is, but it doesn't work. It definitely doesn't work. And you'll have to come back in 15 minutes to find out more. But Shrey, thank you so very, very, very much. That talk really resonated with our audience. It resonated with me. It resonated with my hundreds of ducks. And thank you.
Thank you for having me.